Welcome to Microlecture 10 on acid-base chemistry. This topic is covered way differently in organic chemistry than it was in general chemistry. So we're mainly going to focus on acids and bases as species that are present in chemical reactivity. So maybe as reactants, products, acid or base catalysts. We are going to apply everything that we talk about here, for example, curved arrow notation and pushing electrons, to all of the rest of the reactions that we cover this quarter. The last point of comparison is that it's much less math in organic chemistry. Okay, so we're going to review acid-base chemistry in terms of something you've probably seen before. So let's say we have a water molecule and it's reacting with an acid. Let's use HCl as our strong acid, and this is a reversible equilibrium reaction, so I'm using equilibrium arrows here. We can predict the product. We can also label the acid base, conjugate acid, and conjugate base. Clearly HCl is the acid reactant, therefore the water is the base. And we can predict the product then. We're using Bronsted-Lowry's theory of acidity and basicity when we're talking about proton transfers. Acids donate protons, and bases accept the protons, and so as a base, it would accept this proton, and that would create this hydronium product, and the other product formed is a chloride anion. So again, should look pretty familiar to you. The hydronium is the conjugate acid, and the chloride is the conjugate base. All right, and so we want to think about this in terms of electrons moving around now. Okay, so far this is all general chemistry. We're going to use curved arrow notation to push electrons and draw a mechanism for this reaction. We're going to start with the base. The base bears the electrons, okay? It's always the source of electrons. I'm going to choose one of the two lone pairs sitting on oxygen, and that lone pair of electrons is going to be used to form a bond to the hydrogen of HCl. Okay, that's how water picks up that proton. The bond between H and Cl breaks then and gives a lone pair of electrons to chlorine, generating the chloride anion. Okay, and so this is curved arrow formalism. We're going to use curved arrows again and again and again in this course, and so you can get around it. You must master this skill. Okay, so let's cover a couple of more examples, and these will be less familiar because these acid-base reactions are in the context of organic chemistry. So let's take a good organic acid like acetic acid, and we'll react a base, perhaps ammonia, and that's an acid-base equilibrium where the carboxylic acid here is our acid, ammonia is our base. We could predict the products. If we think about the fact that an acid is a proton donor, then we know that we would form this conjugate, and the other product is ammonia but protonated. So ammonium And we understand that this is our conjugate base, and ammonium is our conjugate acid. So let's go ahead and provide the curved arrows. How are we going to describe this in terms of electron movement? I'm going to look towards my base first, see if I have a lone pair of electrons. I do. It's on nitrogen. The nitrogen is the atom that picks up the proton anyway, so that's exactly what we're going to show here. We form a bond between nitrogen and hydrogen, and then kick the electrons off onto the oxygen atom there. Let's look at another example besides this one. Squeeze in another organic compound below here. This one is a triple bond, so all bonds drawn from triply bonded carbon atoms, or sp hybridized carbon atoms, must be shown in a straight line. Bond angles there are 180 degrees. Just a couple of reminders there. And we have a strong base here with a negative charge on nitrogen. Alright, so we can clearly see with all of that negative charge, this is going to be our base, and the other compound therefore must be our acid, and we can predict the products as follows. Okay, the conjugate base has a negative charge on that terminal carbon, and ammonia is our conjugate acid. Now, in terms of electron movement, the negatively charged nitrogen, its lone pairs, one of the two, are going to be used to pick up the terminal proton of this carbon-carbon triple bond compound, this alkyne. And then when we make a bond to the hydrogen, we have to break a bond from it, and we give those electrons to the terminal carbon. And so there you have it. Two of your first mechanisms in organic chemistry.